All right, we're going to take a look at 2011 free response question number 2 for the AB exam. Here we have a table of values, one of the common questions that you see on the AP free response questions. It says, as a pot of tea cools, the temperature of the tea is modeled by a differential function h, for 0 is less than or equal to t is less than or equal to 10, where time is measured in minutes and temperature, h of t, is measured in degrees Celsius. Values of h of t at selected values of time t are shown in the table above. All right, so let's go ahead and start with part A here. One of our nice easy ones here. Use the data in the table to approximate the rate at which the temperature of the tea is changing at time t equals 3.5. Show computations to lead to your answer. Now remember, rate is just derivative. And the way that we approximate a derivative is find the slope. Now we got to pick the values that are closest to 3.5, and you see that 3.5 is right between 2 and 5. So all we need to do is find the slope. We're going to take y2, 52, minus y1, 60, over x2 minus x1, 2. All right, and this is going to be an approximation to h prime of 3.5. All right. Remember, even though this is a calculator question, we don't have to simplify this. Now we want to make sure that we do have our units, and so this would be in degrees Celsius per minute. Just in case that is an actual point for this, we don't want to leave anything out. And that's all we have to do for that question. So let's take a look at part B. Okay, part B is something we've seen a couple times. All right. Using correct units, explain the meaning of 1/10 integral of 0 to 10 h of t dt in the context of this problem. Use trapezoidal sum with four intervals indicated by the table to estimate 1/10 integral of 0 to 10 h of t dt. All right, so anytime we're trying to explain the meaning, we got to make sure we have three things. What is it? What units? And what time? And if we take a look at this, we have 1/10 and then the integral of 0 to 10. Now if we rewrite it like this is probably a little more familiar, and we just saw one in 2010 when we did that earlier. This is our integral over interval. This is the average value. All right, it's the average value of what? Temperature. Of the tea. All right, that's what it is. What units? In degrees Celsius. And then what time? From t equals 0 to t equals 10 minutes. And make sure you're specific. We're going to say t equals 0 to t equals 10 minutes, or 0 to 10 minutes would work in this case. All right, so that covers our explanation of what this is. Now what we have to do is figure out the approximation using trapezoidal sum. Okay, so we're going to use four intervals. Let me give us a little room here. All right, so we're going to do 1/10 integral of 0 to 10 h of t dt. Is going to be approximately. Don't forget the 1/10. And what we need to do is find the area of all those trapezoids. Now I always like to draw a quick picture. And we know 0 is going to be 66. And this isn't going to be drawn to scale by any means. At 2, this is going to be 60. At 5, this is going to be 52. At 9, it's going to be 44, and at 10, it's going to be 43. So remember, trapezoids, just going to connect all the dots, and remember the height is on the bottom. You got to kind of turn your head to see those trapezoids, and our formula for trapezoid area is 1/2 height base 1 plus base 2. And so we're going to go ahead and just find a bunch of areas. So it's going to be 1/2. First height's 2. Base 1 is 66 plus 60. That's base 2 plus 1/2. Our next height's going to be 3. And that's 60 plus 52. Plus 1/2. Our next height is going to be 4. 52, running out of room, 44. Plus our last one will be 1/2, and a height of 1, 44 plus 43. And again, that'd be in degrees Celsius. Okay, and again, that's our average temperature over that time. And we don't have to simplify, we're going to leave it just like that. Perfect. All right, let's take a look at C here. Evaluate 0 to 10, integral of 0 to 10 of h prime of t. Using correct units, explain the meaning of the expression in the context of the problem. Now, we don't actually have a formula for h prime of t, but remember, if you're integrating h prime of t, that just gives you h of t. Well, if we put 0 to 10, we're going to use that fundamental theorem of calculus part 1, and that's going to give us h of 10 minus h of 0. Well, we have that in our table. That's going to actually be 43 minus 66. All right? And we can actually figure that out if we want, or we could leave it. That's okay. But that'd be negative 23 degrees Celsius. Now, what does that actually mean? Well, this is its temperature at 10 minutes. This is its temperature at time t equals 0. So this is the change in temperature. This is the total change in temperature from t equals 0 minutes to t equals 10 minutes. And if we want to be specific, we can say the temperature decreases by 23 degrees Celsius. Move that up there so you can see that. All right. The scoring guideline does include the decreases, and it might be wise to put that since we are just having a negative value in there. But I don't see why total change in temperature would be marked incorrect. Okay, and that finishes up C. So let's take a look at D. D's a little bit more in depth. And usually D tends to be a little bit more. At time t equals 0, biscuits with temperature 100 degrees Celsius were removed from an oven. The temperature of the biscuits at time t is modeled by the differential function b, for which it is known that b prime of t equals negative 13.84 e to the negative 0.173 t. Using the given models at time t equals 10, how much cooler are the biscuits than the t? All right, so what do we know? We know that b prime of t equals negative 13.84 e to negative 0.173 t. We also know the initial temperature. We know b of 0 equals 100. We need to figure out what is the temperature at 10 and compare it to the t. Well, this is the same thing as earlier. We have an initial condition, we have a rate, and we got to find another one. So this is going to be that fundamental theorem of calculus part 1 again. We use that a lot. So we're going to integrate 0 to 10 of b prime of t dt, and that's going to give us b of 10 minus b of 0. So we can do this right in the calculator again. So let's take out that calculator. And I'm going to do integral math 9, 0 to 10 of negative 13.84 e to the negative 0.173 x dx. All right, and we get negative 65.817. All right, b of 10 is what we're looking for. B of 0, we already said was 100, so all we have to do is add 100 over there. All right, and we get B of 10 is 34.183 degrees Celsius. That's the temperature of the biscuits at time t equals 10. Well, now we got to figure out how much cooler are the biscuits than the tea. Well, at time t equals 10, h of 10 is 43. So all we have to do is take 43 minus 34.183, which is going to give us 8.817 degrees Celsius cooler. And that's our answer for, let me put that up there, that is our answer for part D, and that wraps up question number 2.